So lesson 37 has a strange word in there that you may not be familiar with. We're going to talk about lines as a locus. And I'm wondering if there's anybody who has taken Latin or anybody who just looks at that word and says, looks kind of like it starts the same way as this other English word. So maybe that's what it means. It does not have a T on the end of it. It is not an insect. Anybody brave enough to make a guess of what you think locus might possibly mean? Come on, somebody can be brave. You know the English language. You can at least make a guess. You can type in chat, or you can unmute if you're home, or you can shout it out if you're here in the classroom. You can think of some other English words that starts with L-O-C. Location, and that's exactly right. It comes from the Latin word that means place. So I want to get to where you guys are feeling comfortable enough. It's like, it's okay to make a guess. It may or may not be right. Sometimes it will be, sometimes it won't, and that's fine. That's how inventors come up with things and engineers come up with new designs. They toss something out. Some of the ideas work and some of them don't quite work, but it gives somebody else an idea to build on. So that's what we're shooting for here. So locus is the Latin word for place. And in math, we use it to describe all kinds of things. We describe how far away one type of shape is from some other geometric figure. So you've actually already done quite a few of these. You just didn't know that you had done them before. You've done ones over the years where you've had a fixed point, and then you have a little device in your hand that lets you put that pointer down on the dot, and then you set a certain distance, maybe 3 centimeters, and you draw all of the points that are 3 centimeters away from that pointer on the device. What do you draw when you do that? If we are talking about 2 dimensions, we do indeed have a circle. If the stylus will decide to cooperate. There we go. So if we are in 2D, we might have a circle, something like that. What if I said, though, you're not going to use a compass to draw this in 2D. What if I said, imagine a fixed point, a center point in 3D space? What shape would you get if you talked about everything that is exactly 3 centimeters away from that fixed point? Say a little louder. Sphere, that's perfect. If we are in 3D, then we are talking about a sphere. So let's try a few more of these and then we'll move on to a line as a locus, because it's going to be a little bit stranger than what we're doing right now. This time, let's start out with a circle. And let's suppose that that circle happens to have a radius of 12. So that line that I drew for the radius is not actually part of the circle. That's just describing how big the circle happens to be. What if I wanted, and we're only going to do 2D on this one or it'll get too weird. What if I wanted to talk about all of the points that are 10 inches away from the circle? What would that look like? What would we have then? Sorry, I missed comments in the chat earlier. Thanks, John. Just glad you made it. How would I have if I go 10 inches away from that circle? Kenny, what do you think? If I have this circle and then I go 10 inches away from it, what would I have? Okay, so I could, and I think I've actually got one down here I can maybe grab and pull up so it'll look a little bit better than if I try to draw it freehand. So I could go like this, so that now I have a circle with a radius of 22. So if that's 10, that would mean my whole radius is now 22. Is that the only direction I could go on the screen and be 10 inches away from the circle? Is there any place else I could go? My original radius was 12. Is there any place else I could go and only go 10 inches away? Elliot? I could go inside that original circle, and this one I'll just attempt to draw. And so then I'd have a little bitty radius here of 2, if that part was also 10. So this locus would be those 2 blue circles. One with radius 2, one with radius 22, around the same center. Does everybody feel reasonably comfortable with that? Okay, one more here. This time, here is a line. Notice there are arrows on both ends of that line. It does not stop. It's not a line segment. It's going to go forever. Let's stick with just 2 dimensions. What if I went 5 centimeters away from that line? What would I have? What would I have if I went 5 centimeters away? So a line parallel to the green line? Okay, so which way were you going from the green line? Okay, so I could go 5 centimeters away from this green line and have a new line like this that also goes forever. Is that the only place I could go on this screen? Where else could I go? I could also go 5 centimeters down and get this line. So this locus would actually give me the 2 parallel black lines. The green line would not be part of the locus that I get. It's just what I use to get there. But I would get those 2 black lines. So 2 parallel lines if I am in 2D. What if I go 3D? What would I have? So hopefully people at home can see too. So if here's my green line, if I'm using my forearm here for my green line, if I go 5 centimeters above and 5 centimeters below, but if I also let myself go 5 centimeters away from that first line in any direction, what kind of shape will I have? Type in the chat, what kind of shape will we have? You can go ahead and hit enter once you type it. Go ahead and hit enter. So no, we're not going to get a circle if we do that. We are going to get a cylinder, but it's not going to be like a soup can that has a top and a bottom, 2 ends to it. It's going to be a cylinder that goes forever and ever because that green line did not have any end to it. So that kind of makes sense for seeing some of the ways we can describe location, how far away new points are from some original line or point or circle or something. Okay, I want to just kind of start to get a little bit of an idea of that because we will end up doing quite a few of these. The one we're going to focus on today will be the locus definition of a line. For a line, we are going to start off with 2 points that are not on the line. The points on the line are going to be any spot that is the same distance from the point 1 as it is from point 2. And then another point and its distance to point 1 and point 2 are equal to each other. So I'm going to give you a picture of what that looks like. So P1 and P2 are my original points there. They are not going to be on the actual line that I'm talking about. I'm going to be talking about all of the possible XYs. So here's one out here. I'm changing color, but I don't believe it. And if I take the distance from XY to P1, and then I take the distance from XY to P2, those distances are equal. But there are a bunch of other points I could pick where that's also true. I could take one right here so that this distance to P1 is the same as this distance to P2. I could take one over here, and the distance from that point to P1 is the same as the distance from that point to P2. Or I could have picked this point, or this one, 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 or this one. If I took those distances to P1 and P2, for each of those, they'd be the same. If it were possible for me to actually draw every single one of those, I would fill this in with no space in between them, and I would then have this line. And every spot you want to pick on that line is the same distance to P1 as it is to P2. So now what we're going to start doing is we are going to write the equation using the locus definition. So we are going to say that the distance from xy to P1 is equal to the distance from xy to P2. And we're going to use that to actually get the y equals mx plus b for the line that we're talking about. The xy will be the x and the y that we end up with in our y equals mx plus b, no matter what point we pick on that black line. If we plugged its coordinates in, we're going to get something that is true. So first thing we are going to do is to write down what I just said, that the distance from xy to the first point equals the distance from xy to the second point. So the distance must have the square root sign in there. And then from xy to 5, negative 2 is going to be x minus 5 squared plus y minus the negative 2, so y plus 2 squared. Then I am going to take the distance from xy to the other point. So the distance from xy to negative 4, 3 is x minus the negative 4, so x plus 4 squared plus y minus 3 squared. And stop me if anybody sees me making any silly, careless little mistake. If my mind gets ahead of my stylus, don't let me keep writing a whole bunch of mistakes down one after the other. Now, when you are doing these, I want to see the square root sign in there, because if I just say x minus 5 squared plus y plus 2 squared, I have not used the locus definition. That is not the distance. It's not the distance if you don't take the square root. So we are going to get rid of the square roots as the very next step, but I want to see it as you start. So what you're going to do then, once you've written that down, you're just going to square both sides. So now there's no more square root sign. Then we are going to work on simplifying everything, and then we'll get it into y equals mx plus b form. So what I need to do is to expand my x minus 5 squared. So that's going to give me x squared minus 10x plus 25. Then I'm going to expand y plus 2 squared. So I have plus y squared plus 4y plus 4. And then that equals, square root sign's gone on this side too, because I squared both sides, x squared plus 8x plus 16. And then if I expand y minus 3 squared, y squared minus 6y plus 9. Did I get all of that right? Okay, next thing that I need to do then is to simplify, combine like terms, get all of the y's on one side. So I'm going to start by subtracting x squared from both sides, so those go away. And I can also subtract y squared from both sides, so those go away. Since I'm trying to get to y equals form, I want all of the y's on the left, and I have a 4y on the left already. I have a minus 6y on the right, so if I move that to the left, it becomes a plus 6y. 4y plus 6y gives me 10y. Okay, let's get all of the x's over on the right. I had a minus 10x on the left, so it becomes a plus 10x on the right. And I had a plus 8x on the right, so that gives me 18x on the right. Okay, on the left, I had a 25 plus 4. And so if I bring that over to the right, it becomes a minus 29. On the right, I had a 16 plus 9 or plus 25, and I'm going to keep that plus 25 on the right, which means I have 10y equals 18x minus 4. Divide everything by 10 and reduce the fractions. Y equals 9/5 x minus 2/5. So anybody with any questions on what we did there or what's expected on your homework? Okay, and that only leaves reviewing the midpoint formula for today. So midpoint means I start out with 2 points, those where I've got the 2 big red dots, 5, -2, -4, 3. I want the midpoint, so I want this point so that the distance to the first point equals the distance to the second point. And I can imagine those little dotted purple triangles that I've drawn there. And they'd both have a right triangle. The vertical sides would be parallel, the horizontal sides would be parallel. So all of the angles would have to be congruent. So we've got similar triangles, except that we've also got congruent hypotenuses, so we've actually got congruent triangles. So that tells us that this little distance from the y coordinate on my top red point to my green midpoint is the same as the distance from the y coordinate of my green midpoint to my lower red point's y coordinate. So that means that the y for that green point is halfway in between just the 2x coordinates. And anytime you want something that's halfway between two other things, you're just talking about the average. So I want the y that's halfway in between those two original y's, or the average y. Same thing for the x's. That's going to be halfway between the two red x's. So I just need to come up with the average x and the average y. And hopefully you remember this formula that you've been using for the last couple of years. If you want the average x coordinate, you take the two x coordinates you're given, and to get the average or mean, you add and then you divide by 2. To get your average y, to get the y value that's exactly halfway in between, you add the two y's and divide by 2. And that's all you have to do to come up with the coordinates of the midpoint. And I see a number of people writing at home and here in the classroom, so as soon as it looks like everybody's got that down, we'll go back to that picture that I had up there and find the actual coordinates of the midpoint. And that will finish our note taking for today so that we can start checking those two sets. So I have a couple of you writing. All right, looks like maybe we're good to go back to that. So if I had 5, -2 and -4, 3, I need to get the average x, so I'm going to take the 2x coordinates and add them and divide by 2, so 5 plus -4 is 1, so I have a half. Then I'm going to take the 2y coordinates and add them, -2 plus 3, and divide by 2, so again I get a half. And don't forget, a midpoint is a point. It needs to have two coordinates, comma, and parentheses.